Prime Factorization and Greatest Common Factor, GCF. Okay, so we're going to learn how to find the prime factorization of a number because it's going to help us find the greatest common factor, especially when we start dealing with really bigger numbers and variables. Okay, so let's get started here. So the first thing we need to understand is, first of all, what is a prime number and what is a composite number? So we're going to write down these definitions here. So a prime number is an integer. Think about what that is. So a prime number is an integer greater than 1, that has exactly 2 factors, and that's important, exactly 2. All right, and just so you know, the 2 factors are always 1 and itself. So let's just list out some prime numbers. So what's the lowest prime number? All right, so really the lowest prime number is 2, because 1 times 2, 2 and 1 are the factors. That's the lowest one that has 2 different factors. The next one is 3. Is 4 prime? You can do 1 times 4? No, because you can do 2 times 2, so not 4. 5 is prime. 6? No, you can divide by 2. 7. 8. 9? No, 9 is not, because you can do 3 times 3. 10, 11, 12, 13. You get the idea. 14, 15, no, because you can do 5 times 3. 16, 17, 19. Okay, and you can go on forever. There are prime numbers that are very large. Actually, some really large prime numbers they use for coding. We can pause and talk about that. Okay, so those are prime numbers. So then the opposite of a prime number is a composite number. So a composite number, again, is an integer greater than 1. So is an integer greater than 1 that has more than 2 factors. More than 2 factors. So a composite number is an integer greater than 1 that has more than 2 factors. So, I mean, there would be everyone missing here, right? 4, 6, 8, 9, 10, 12. Okay. All right. Now, let's get to what we're going to figure out here. So the prime factorization. Prime factorization. Okay, what is that? So if I ask you for the prime factorization, I want you to basically break a number down into only its prime factors. So it's going to be writing a composite number, right? Because those are the numbers we can break down. Write a composite number as the product of its prime factors. So you have to break the numbers down all the way down to its prime factors. All right, let me show you what I mean here. So, example. If I asked you to find the prime factorization of 48. Some of you will be able to do this in your head, but I'm going to show you kind of what I'm doing in my head. So I'm making a factor tree, and I'm going to break down 48 and then keep going until I only have prime numbers. So what times what is 48? That's what I'm thinking in my head. So maybe 6 times 8. Now, is 6 a prime number? No, I can break it down, so I'm going to. 6 could be 2 times 3. As soon as you get a prime number, I like to circle it so I know the branch kind of stops right there. Right, those are both prime. 8, I could do 2 times 4. 2 is prime. 4 we could still break down. 2 times 2. Okay, so what is the prime factorization of 48? And you can write it in any order. I usually write from the lowest factor to the highest, so it's 2 times 2 times 2 times 2, right? 1, 2, 3, 4 2s, and a 3. A better way to write that, 2 to the 4th times 3. There is your prime factorization for 48. Now, just let's say I looked at 48 differently. Maybe some of you said, how about 2 and 24? If you started like that, let's see what happens. How do you break down 24? Maybe 2 and 12? Break down 12. 2 and 6? Break down 6. 2 and 3? We should get the same thing. 1, 2, 3, 4 2s and a 3. Yeah. So no matter how you break down the number, if you're going all the way to the prime factors, we will always get the same answer. It's kind of cool. It's like the prime factorization is the code for that number, and every number has its own unique code. Kind of cool. All right, try a couple on your own, and then we'll go over the answers. Try 60 and try 825. Ooh. All right, good luck. Okay, for 60, I'll show you what I did. I did 6 and 10. That's 2 and 3. That's 2 and 5. So I got 2 to the 2nd times 3 times 5. 825. I know 5 goes into it. And that would leave me with 165. Oh, 5 goes into that. That leaves me with 33. 33, 3 and 11. Ooh, 11's prime. 3's prime. So I got 3 times 5 to the 2nd times 11. That's the prime factorization for 825. Okay, nice. Now, why is this useful? Okay, I'm going to show you that next, because we're going to use this to find the greatest common factor. Okay, so what am I up to here? I think I'm up to number 4. So let's write down greatest common factor. Greatest common factor. Okay. Now, I'm not really sure how your group did it in years past, but if you think about it, if I asked you for find the greatest common factor of 16 and 20, some of you can see it in your head already. Some of you, if I kind of listed out the factors, can probably see it. So if I listed out what are the factors of 16, you got 1 times 16, 2 times 8, and 4 times 4, right? So those are all the factors of 16. Let's do the same thing for 20. You got 1 times 20, 2 and 10, 4 and 5. So those are all the factors of 20. Now, what's the greatest common factor? So the biggest number that they both have in common. They both have a 1, but let's get bigger. 2, they both have a 2. 4 is it? So the greatest common factor of 16 and 20 is 4. And you're thinking, that's a fine way, why don't we just do it like that? Totally can. But what we're going to do is we're going to get bigger numbers, and it gets to be a pain to write out all the factors, and if you miss one, you might miss the greatest common factor. Okay, so I'm going to show you an easier method. So I don't know what you want to call this, the easier method, where we're going to use the prime factorization, since we just learned it. So easier method, use the prime factorization. Okay. So we're going to kind of do an example. How about 40 and 60? And we're going to write the steps at the same time. Okay, let me move this up. First of all, can you tell what it is? Greatest common factor of 40 and 60? It's going to be 20, right? So yeah, this is an easy one, but let's use it to find the steps. Okay. So first step is you're going to find the prime factorization of both numbers. Can I fit this? Both numbers. Now, if you need to do a factor tree, do that. Here's what I do. I kind of do the factor tree in my head, to be honest. Like, I break down the 40. I divide it by 2. I know 2 is prime, so I write it down. Now I'm down to 20, right? Do another 2. Now I'm down to 10. 2, 5. So I kind of did this in my head. I did, 2 times 20. I wrote it down. 2 times 10. If you can do it in your head, it's fine. If you need to do a little factor tree, that's fine. All right, so if I do 60, divide it by 2, I'm down to 30. Divide that by 2, I'm down to 15, which is 3 times 5. So there's the prime factorizations for 40 and 60. That's step 1. There's only 3 steps. All right. Step 2 is you're going to circle common factors. My favorite part. So if they both have it, you're going to put it in a circle. So they both have a 2. And it doesn't have to be right on top of each other. You could circle this way. They both have a 2. Ooh, they both have a 5. Once you have it in a circle, you can't recircle it. So that 2 is going to be left alone. There's nothing to match the 3. All right, and then the last step is you're going to multiply the circled factors together. And the trick to this is each circle counts as one factor. What does that mean? So multiply the circled factors together. Each circle counts as one factor. So what I mean is this circle of 2's counts as 1, 2 in the GCF. This circle of 2's counts as 1, 2 in the GCF. This circle of 5's counts as 1, 5 in the GCF. You multiply those together. 2 times 2 is 4. 4 times 5 is 20. And you are done. So the GCF, we knew it, of 40 and 60 is 20. All right, so those are the steps. Those are really the main part of the notes. So now we'll just practice some. All right, so let's try. Let's try the GCF of 72 and 225. I like to set it up before I do anything. Makes me happy. This is the work I need to see, folks. Here, I'll leave the steps there. Okay, so go ahead, I'll pause it, try to break these down, and then go from there. All right, so hopefully you broke this down. You got 3 2's and 2 3's. 225 is 2 3's and 2 5's. What do they have in common? They have this 3. They have this 3. That's it. So 3 times 3, the GCF is 9. Okay, let's try another one. GCF of 121 and 236. Pause. All right, well, 121 is 11 times 11. 236 is 2, 2, and 59, which is prime. Whoa. Wait a second. There's nothing to circle. What factor does every number have that we didn't write down that you really could circle? Boom. 1. So if there is nothing in common, you know they at least have a 1 in common, right? You can always do 1 times the number. When this happens, these numbers are called something special. They're called relatively, oh my gosh, I'm sorry, relatively prime. So when your GCF is equal to 1, you are called relatively prime. Okie doke. We'll do 2 more. I'll write them down and you can try them. So let's try the GCF of 36. Oh, I might have to do this one. I'll do this one with you. A cubed B and 60A squared. Let's do this one first. All right, so let's set it up. 36A cubed B okay. 36 I know is 2233. Now the letters we're just going to expand out here. A to the third, we're going to write A. And then there's a B. 60, I know this one too. 2, 2, 3, 5, and 2 A's. All right, circle. Even letters, if they have letters in common, we're going to circle them. Okie doke. So we've got 2 times 2 times 3 times A times A. That's 4, 3, that's 12. A to the second power is your GCF. All right, one more for fun. 75 x to the 4th y squared and 120 x squared y. Okay, so 75 x to the 4th y squared, 120 x squared y. All right, 75 is 355. I've got 4 x's and 2 y's. 120, 3 2's, a 3 and a 5, 2 x's and a y. Woo! All right, it's got a 3. Got a 5. Sometimes people put lines, X and an X. I don't know if that's, ooh, and a Y. If you like doing the line instead of a circle, I'm fine with that. All right, so we've got 3 times 5 times X times Y. What is that? That is 15x squared Y. There we go. All right, good job, everybody.